Jody is buying a scrapbook and sheets of designer paper. She has $40. That's all she has, and needs at least $18.25 to buy the scrapbook. So that's the first thing she's going to buy is the actual scrapbook. And then each sheet of designer paper is 34 more cents after that. So our inequality would look something like this. We're going to write $18. Oh, hold on a second here. Ignore that. We're going to go $18.25, and that's the scrapbook. You could write that under there, scrap book. Okay, and then she's also going to add more paper to it. That's this fancy designer paper for 34 cents per piece of paper. All right, how many sheets can she buy? That's our variable. So we say let X equal number of sheets of paper. Okay, and so we're going to go 34 cents, right, like this, and we're going to multiply by X. You could call it P for paper if you really wanted to. And then right here it says at least that much. And so she only has $40. She has 40, so we want to stay under budget, all right? And so she's going to spend less than or equal to, because it's going to be under $40. Sort of goofy wording there at least, she has $40 and we don't want to spend more than that. And you want to reserve $18.25 at the minimum in order to for the scrapbook cost. Okay, so, and then this would be $40 right here. So we got to solve this now. The inequality, you're going to write right here, $18.25 plus 34 cents multiplied by X, and then it's less than or equal to $40. Okay, so then you're going to solve that, and we're going to subtract $18 and ignore that scrapbook right there. Anyway, and so we're going to do minus $18.25 from each side, minus $18.25. And what do we have after that? Well, these will cross out. I drop down my 34 cents. X is still less than or equal to, and we'll take $40 and we'll subtract 18.25. Use calculator, that's just fine. 21.75 is what we would have. Then I divide by 34 cents. Divide by 34 cents on each side. That allows me to cross those out. And then my X is going to be less than or equal to the number of pieces of paper I can actually buy. And so I take my 21.75, divide by 0.34, and I get 63.97. So that's 63.97. Now it's tempting to just round it up to 64, but we have to say, okay, wait, hold on. If I buy this many pieces of paper, then I'm actually going to be at $40 exactly. And so I need to be less than that amount. And so I actually round it down to 63. And the reason for that is if I buy 64 sheets of paper, you're going to go over your $40 that you have in your pocket. You can't go over $40, let's say. And so that actually changes things a little bit. So you can't go over that right there. All right, let's move down to our next problem. Learning target 3 says I can do some compound inequalities. So let's look at this. We introduced these compound inequalities. Let's write this. It says number 1 right here, write the sentence as an inequality. It says there's a number X and it's at least. So there's two things going on, two inequalities. It's at least this, so it's going to be greater than or equal to 2. And then it's less than 6, so we're going to go less than 6, right, like that. All right, and we want the X value to include both of these. So we're going to say X is greater than or equal to 2, but it's also going to be less than 6. You could write it like this, and it says and. You could write and in between, and that's one way you could write it, but typically what we like to do with and inequalities, if it's going to satisfy both of these at the same exact time, because it's an and statement, then it's going to be we can say it's going to be less than, and I place my less than like that with my 6 over here. It is less than 6, but greater than or equal to 2. You could write it that way, or you could write it this way. Actually, this probably makes a little more sense, is to write it right like this, with the 2 over here and the 6 over here. So it's less than 6, greater than or equal to 2. Either way, all of those are technically true and correct as long as you wrote an and in between them. All right, let's go down to the next problem. Clear this and move down here. So number 2, it says match the compound inequality to the graph. All right, so we want to just say if it's an or statement, it'll be away from each other. And so if it's or, then it'll be like this. All right, and we just know that. If it's and, see this one right here, this notation is an and inequality. All right, because it includes two inequalities that are acting on the same x. These will actually be an interval, right, like this. So the only one that has an interval like that is C right away. Do I have to do a lot of work to, no, you just kind of have to know what they look like, all right? And so this one right here is an or inequality with solid filled in circles. This one has open circles, right, because they're not equal to. This one has solid and filled in, but they're or, this one's an or inequality, so they will go in opposite directions. Is there only one that does that? Yep, B, right? And so far I have that. And this first one right up here is the not including and going in opposite directions. Do we have anyone like that? Yeah, we have D. D looks like that, right? And must have the last one here, but double check. This one will be an interval because it's an and inequality. And inequalities are an interval from one number to another number. It's in between two numbers. This would be in between 1 and 7. All right. So that would actually be A as our correct answer right up there. All right, so we see our matching. Let's go down to number 3, and this is our last question on this page, and kind of work through this particular example real quick. Number 3, an iPhone has an operative temperature ranges that it actually really, really likes. And so we would have, like, say, from -20 at a minimum, all the way up to 45 degrees Celsius. And so degrees Celsius is kind of weird a little bit, but in science we work with Celsius a lot. So 45 degrees Celsius. And so that's our range. That's the range of temperatures. I personally have left my cell phone out in the sunshine, just blazing hot in the summer. And it actually does give you that message. The temperature message says, oh, we got a problem. Go cool this phone down. It's too hot. When the temperature is outside of this range, the device will not work. Create a compound inequality that represents this for all temperatures. So it would be like this. X is all temperatures that the iPhone will not work. You see this right here? Will not work. Not the temperatures that it will work. This is the will work in between the two. We actually want everything above that and everything below that. All right, so we're going to say everything that is less than -20 will not work. And, or we don't write and, but we write or X is going to be greater than. And so we would put a 45 right here. So it's have to be greater than. This is will not work above that and below that. All right, so move on to the next page and go through those next answers. Remember, rewind, fast forward as needed.